Hello and welcome. Today we are going to talk about digital inputs and digital outputs. But before we talk about digital inputs and digital outputs, we need to understand these words, inputs and outputs. Correct? Well, on digital systems or on computer systems, we have some processing data process inside of my digital system. For example, here is my data, and maybe I need to multiply it by 2, and I don't know, maybe after this multiplication I need to perform an addition with data 2 or something like that. We need to process this data. We need to perform operations for this data, whether if they are arithmetical operations or they are logical operations, or maybe we just need to store this data. We work with data. It could be your password, it could be your username, it could be your age, any information that we need during a program. That's data. And this data can be inserted into my program by the user. And anytime that we store data, that we insert data into my program, this is my program or my process, this is called an input. Correct? Any data that I need to include into my program, and maybe I take this data from a user, or maybe from a sensor, from the environment. This is an input, data that I am going to use during my program, and I need to introduce this data into my program. After I have this kind of process, I have a result, and I want to display this result so the user can take a decision, and then this is called output. Correct? Any data that I want to send to the user, or maybe send it to the environment, it is called an output. For example, I can have a display, and I can display here the username or the password or something like that. I want to display this into a screen, so this is an output. Also, I can have a light bulb, and then when something happens here in my process, I turn on this light bulb, and so I have some output information for the user or for the environment. Also, I can use a motor to move any mechanical element, and this is also a output. Correct? So any data that I insert into my program, or that the program takes this data from the environment, it's an output, input. And any data that I take from the program to the environment, whether for the user or for the environment, this can be for the user, also maybe this can be for the user, and this is for the environment, because the motor is going to move maybe a gear or a mechanism. So it is an output. So that's it. Input, data that I insert into the program. Output, data that I take from the program. Correct? Now, the second word is digital. Correct? Basically, on computer systems, we have two kinds of data. It can be digital, and that means that it only has two values, 0 or 1, and that's it. A digital input or a digital output only has two values, 0 or 1, yes or not, on or off. Do you get it? Oh, sorry, my mistake. It's off and on. But only two values. And this is digital. Of course, you can have two digital outputs. You can put them together, and then you can have several values. You see, with two digital outputs, we can have four combinations, and then we have more options. But we get this combination using single digital outputs or inputs. So basically, digital inputs or outputs are data that can be represented by two states: yes or not, right or wrong, on, off, 0, 1. Now, we have another kind of data that is the analogical data. And right now we are not going to use this. I just want you to know about this. But analogical data, it's continuous data with several values. You see, something like this. And it has a 0 value, and maybe it has a 1 value, and maybe it has 5 value, and so on. And from 0 to 1 you can have 0.1, 0.2, 0.3, and so on. And again, from 0.1 to 0.2 you have several values. You can have something like this, and so on. And again, from this to this you have several values. So you have infinite values, and that's the description for analogical data. You have a lot of values. You actually have infinite values, and this kind of data, it's useful. We actually have some digital inputs, analogical inputs on the Arduino, and we are going to use them later. Right now I just want you to know that we have digital data, that is data that can be expressed with only two values, 0 or 1. And we have analogical data that can be expressed with a lot of values, infinite values. Correct? So today we are just going to focus on digital data. So let me delete this, and that's it. So logical data, it's usually produced by some kind of sensors. Some of them can be mechanical sensors, or some electronical sensors can be adapted to produce this kind of data. So the basic one, it's a button, correct? If you have a button, a mechanical button, and if you don't press the button, you have 0 value. And when you press the button, you have when you don't press the button, you don't have flow of electrons. All the electrons gather here, and then you have 0 electrons, 0 value. And when you press the button, all the electrons moves this way, and then you have a 1 value. So push buttons are the most common digital inputs, correct? Now, for digital outputs we have several options, but again the most common is the light emission diode. That is this little guy, do you remember? Something like this. And then if you have 0 volts here, I'm going to use again the button. If you don't press the button, you have 5 volts here, and you have ground here. So if you don't press the button, you have 0 electrons moving through the LED, and then this is turned off. When you press the button like this, all these electrons moves through the LED, and it turns on. So we can use this element as a digital output because it can express data in two states: turned on or turned off. correct? So the basic element to create digital inputs is the push buttons, and the basic element to produce or to express a digital output is the LED. So now let us create a circuit in order to use these digital inputs and digital outputs in the Arduino. So as you know, Arduino has several ports, several connection elements, and then we can use any of them. Maybe port 0, we are going to use port 0 as a digital input. So the way to express this electronically is something like this, really easy. A little box and a label, port 0, correct? And as I told you, we are going to use this as a digital input. So in order to produce a digital input, we are going to use the button like this, and then we need to send a electrical signal. This electrical signal, it's a voltage signal. On the Arduino, the zero value, the zero digital value, it's equals to 0 volts. Do you remember? Voltage, it's the force that we apply to the electrons to move them. So if we do not apply any force, we are going to have a digital zero value. And the want value, it's equals to 5 volts, correct? These voltage levels might change depending on the element that you are working on. Right now on the Arduino we are going to work with 0 volts and 5 volts. So if I connect 5 volts to this port, I have an input value 1. If I connect 0 volts, I have a digital input equals to 0. So I need to connect my button to 5 volts. And maybe we can express this like this. 5 volts, correct? If you check, you have this kind of label on the Arduino, so you can get 5 volt signals from the Arduino. I am going to show you how to do this. I just want to create my circuit, correct? Now when I press the button, when I do something like this, the 5 volts comes this way, and that's it. I have my digital input equals to 1. But if I don't press the button, we have an quite interesting phenomena. That is that I don't have any voltage here, any real voltage, something that I want to introduce into my input. But guess what? All around you we have electrons. We have electrons moving into the air, we have electrons moving in our body, and we have electrons also being irradiated by your television, by your cell phone, by the light bulbs at your room. So we have these electrons moving around the air, and then some of these electrons gather together here, and then I don't have 0 volts here. I have maybe, I'm just saying something, 0.1 volts or maybe 0.2 volts or something like that, correct? So a digital input only understands 0 value or 5 value. If we have another value, the circuit can get confused. So we need to be sure that I have 0 volts in my port when I don't have any electrical connection. So in order to do this, we use this kind of electrical connection. I'm going to draw it right now. So in this part, I'm going to use a resistance, and this resistance could be 313 ohms, or also it can be 217 ohms. It's not a big deal. Actually, the best option, on my experience, it's 1 kilo ohm. But you don't have 1 kilo ohm on your kit, so don't worry. You can use whether 313 or 217, it's fine. And then you need to connect this to ground. This is called GND. You have this port on the Arduino, and this is considered a 0 volts value. So when you connect something to GND, you can be sure that you have 0 volts. So again, if we have the radiation all around the circuit that we know we have, and all the electrons gather here together, instead of coming this way, the electrons are going to follow this circuit, and then you can be sure that you have 0 volts in your input. So that's why you use this kind of connection in order to ensure 0 volts input on my port. Correct? Let me delete all of this, and this is my digital input circuit. Digital input circuit. Now I want to create a digital output, and for this again I'm going to use a port of my Arduino. This time I'm going to use port number 1, and then I'm going to use a digital output. I told you that the best option, or the most common option for digital outputs, is the LED. So I'm going to connect a LED in this way, and remember, this is the negative part of the LED. So this has to be connected to 0 volts, because my port is going to produce 0 volts if I have a low value or a negative value on my digital output. And so 0 volts and 0 volts, there is no voltage, there is no force to move the electrons, and the LED is not going to turn on. But if I have a digital output equals to 1, I'm going to have 5 volts here, and then I have positive in this connection and negative in this connection. The electrons moves this way. Actually they move from negative to positive, but it's okay, it doesn't matter. We have these electrons moving, and I have light. So this is my digital output. But there is a problem. Remember that we need to control electrons moving through an element. Remember that if we don't have control in these electrons, all the electrons are going to move at the same time, and then I can burn my electronical device, whether the LED, or maybe I can burn the Arduino port. So we need to be careful. We need to limit the quantity of electrons moving from the port to the ground. And for this we use a resistance. Do you remember I told you that a resistance is used to limit the quantity of electrons moving through the circuit? So I'm going to include again a resistance, and I'm going to connect to ground again. And the value for this resistance is also 313 ohms. And that's it. I have my digital output. This is digital output circuit. Correct? This is my circuit. Now I need to build this physically, and that's what we are going to do right now.